Question 1. 6 points in a plane be joined in all possible ways by indefinite straight lines, and if no two of them be coincident or parallel, no three of pass through the same point. With the expectation of the original 6 points, the number of distinct points of intersection is equal to, we have four options: A 105, B 45, C 51, and D none of this. Number of lines from 6 points can be written as 6 of C2 equal to, that is 15. Points of intersection obtained from these lines can be written as, that is 15 C of 2 equal to, that is 105. Now we find the number of times the original 6 points come. Consider a point, that is A1, joining A1 to remaining 5 points. If we make 5 points, 1, 2, 3, 4, 5. If we join these points with A1, we get 5 lines, that is 1, 2, 3, 4, 5. If we see, we keep this as L1, L2, L3, L4, and L5. Any two lines from this 5 lines gives A1 as a point of intersection. If we see, line 1 and line 2 are getting intersect at point A1, or we can see L3 or L4 getting intersect at point A1. So therefore A1 come as 5 of C2 equal to 10 times in 105 points of intersection. Similarly, in case with other 5 points, therefore we get as 6 original points come as 6 into 10, which is equal to 60 times in point of intersection. Hence the number of distinct point of intersection can be given as 105 minus of 60 plus of 6, which is equal to 51, which is our option C. Therefore option C is a correct answer. Question 2. There are m points on a straight line AB and n point on another line AC. None of them being the point A. Triangle are formed from these points has vertices when A is excluded to when A is included. Then the ratio of the number of triangles in the two cases is, we have four options. We'll take two cases, that is case 1 and case 2. In case 1, we exclude A, that is A is excluded. So number of triangles will be equal to selection of 2 points from AB and 1 point from AC plus selection of 1 point from AB and 2 points from AC. So we get this as MC of 2, NC of 1 plus MC of 1, NC of 2, which is equal to half of M plus N minus 2 Mn, half of M plus N minus of 2 Mn. So in case 2, when A is included, the triangles with one vertex at A. Is equal to selection of one point from AB and one point from AC. That is equal to M into N. This can be written as Mn plus of half of Mn m plus n minus 2, that is equal to, we get as half of Mn m plus n. Further solving this, we take required ratio, that is m plus n minus of 2 upon m plus n. We take the ratio of case 1 and case 2, so we get the answer m plus n minus of 2 upon m plus n, which is our option A. Therefore, option A is a correct answer. Question 3. There are n straight lines in a plane, no two of which are parallel and no three passes through the same point. The point of intersection are joined, then the number of fresh lines thus obtained is, we have four options given. Since no two lines are parallel and no three are congruent, therefore n straight lines intersect at n of C2 equal to n. Say points, that is, we can say this as points. Since 2 points are required to determine a straight line, therefore the total number of lines obtained by joining n points can be written as n of C2. But in this, each old line has been counted as n minus of 1 C of 2 times. Since on each old line there will be n minus 1 point of intersection made by the remaining n minus 1 lines. So hence the required number of fresh line is n of C2 minus of n into n minus 1 C of 2 equal to n into n minus 1 by 2 minus of n minus of 1 n minus of 2 upon 2. Further solving this, we get as n of C2 minus 1 upon 2 minus n minus 1 n minus 2 upon 2, which is equal to n into n minus 1 n minus 2 n minus 3 upon 8, which we get as option C, that is n minus 1 n minus 2 n minus 3 upon 8. Therefore option C is a correct answer. Question 4. If P of n comma r is equal to 1680 and C of n comma r is equal to 70, then 69 into n plus r factorial is equal to, we have five options given, that is A 128, B 576, C 256 and D 625 and E 1152. So we have P of n comma r is equal to 1680, which is n factorial of n minus r factorial, it equal to what is 1680. And we have C of n comma r, which is equal to 70, which can be written as n factorial r factorial n minus r factorial equal to 70. So we can substitute the value of n factorial upon n minus r factorial, that is 1680, in this part, that we get as 1680 upon r factorial equal to 70. Further solving this, we get r factorial is equal to 1680 upon 70. We get this as 24. Therefore, we get r is equal to 4. Therefore, since we know have p of n comma 4 is equal to 1680, so this can be written as n of n minus 1, n minus 2, n minus 3, which is equal to 1680. So further solving this, we get n is equal to 8. So 8 into, substituting the value of n, we get 8, 7 into 6 into 5, which is equal to 1680. That is nothing but 69 of n plus of r factorial, which is equal to 69 into 8 plus of 4 factorial, which we get the value of n as 8 and r as 4. Further solving this, we get as 552 plus of 24, which is equal to 576, which is our option B. Therefore, option B is the correct answer. Question 5. Number of divisor of n is equal to 38808 except 1 and n is. We have four options: A 70, B 68, C 72 and D 74. Since we have 38808, which can be written as 8 into 4851. Further decreasing to its new least level can be written as 8 into 9 into 539 equal to 8 into 9 into 5 into 7 into 11, which can be written as 2 square into 3 square plus of 7 square into 11. So number of divisor, that is we get as 3 plus 1, 2 plus 1, 2 plus 1 and 1 plus 1, which is equal to 72. This includes two divisors 1 and 3, 8808, and the required number of divisors is equal to 72 minus of 2, which is equal to 70, which is our option A. Therefore, option A is the correct answer. Question 6. If n of P4 is equal to 24 into n of C5, then the value of n is, we have four options: A10, B15, C9 and D5. Given n of P4 equal to 24 of n of C5. So in this, therefore we have n of n minus 1, n minus 2 and n minus 3, which can be written as 24 into n of n minus 1, n minus 2, n minus 3, n minus 4 upon 5, 4, 3, 2 and 1. For the solving, we get 1 is equal to n minus of 4 upon 5, which is solving for n, we get n minus 4 is equal to 5, that is n is equal to 9, which is our option C. Therefore, option C is the correct answer. Question 7. If NP is equal to 30240 and n of C R is equal to 252, then the order pair of n comma r is equal to. We have four options, that is A 12 by 12 comma 6, B 10 comma 5, C 9 comma 4 and D 16 comma 7. Given that n of P r is equal to 30240 and n of C r is equal to 252. Solving this, we can write n of P r can be n factorial upon n minus r factorial, which is equal to 30240 and n factorial upon n minus r factorial which is equal to 252. Further solving this, we get r factorial which is equal to 30240 252 which is equal to 120. Please know that we substitute the value of 30240 in n factorial upon n minus r factorial, which we see over here. So we get r is equal to 5 n factorial upon n minus 5 of factorial is equal to 30240. Therefore, solving this, we get n of n minus 1, n minus 2, n minus 3, n minus 4 equal to 30240. Solving this further, we get we check for LHS, that is n of n minus 1, n minus 2, n minus 3, and n minus 4. We see that 10, that is n is equal to 10, can be substituted in this, and we find that 10 in this there is in present of n, we can write as 10 minus of 1, 10 minus of 2, 10 minus of 3, 10 minus of 4, which we get as 30240. So we have n is equal to 10 and r is equal to 5, which the required order pair can be as 10, 5, which is our option B. Therefore, option B is the correct answer. Question 8. A question paper is divided into 2 A and B, and each part contains 5 questions. The number of ways in which a candidate can answer 6 questions selecting at least 2 questions from each part is, we have 4 options: A 80, B 100, C 200, and D none of this. The number of ways that the candidate may select 2 questions from A and from B, that is 2 questions from A and 4 from B, equal to, can be written as 5 of C2 into 5 of C4. 3 questions from A and 3 from B, can be written as 5 of C3 into 5 of C3. And 4 questions from A and 2 from B, can be written as 5 of C4 into 5 of C2. If we calculate this, we get answer as 200 for every 2 questions from A and 4 from B, for 3 questions from A and 3 from B. We solve this, we get answer as 200 in every point. So therefore, C is a correct answer, that is the total number of ways are 200. Question 9. How many numbers lying between 10 and 1000 can be formed from the digits 1, 2, 3, 4, 5, 6, 7, 8, 9? Repetition is allowed. We have 4 options: A 1024, B 810, C 2346, and D none of this. Between 10 and 1000, the numbers are of 2 digits and 3 digits. Since repetition is allowed, so each digit can be filled in 9 ways. Therefore, the number of 2-digit numbers can be equal to 9 into 9, that is equal to 81. And number of 3-digit numbers can be given as 9 into 9 into 9, which is equal to 729. Hence, the total ways can be given as 81 plus of 729, which is equal to 810, which is our option B. Therefore, option B is the correct answer. Question: there are 4 balls of different colors and 4 boxes of colors same as those of 7 of the balls. The number of ways in which the balls, one in each box, could be placed such that a ball does not go to box of its own color. As we have 4 options: A8, B7, C9 and D none of this. Since number of D arrangement in such a problems is given by n factorial, n minus of 1 upon 1 factorial plus 1 upon 2 factorial minus of 3 factorial plus 1 upon 4 factorial minus continue, that is minus 1 raised to n upon 1 factor n factorial. So number of D arrangements is equal to 4 factorial 1 upon 2 factorial minus of 1 upon 3 factorial plus of 1 upon 4 factorial, which is equal to, solving this we get 12 minus of 4 plus of 1, which is equal to 9, which is our option C. Therefore option C is the correct answer. Question 11. 10 different letters of an alphabet are given. Words with 5 letters are formed from this given letters. Then the number of words which have at least one letter repeated is, we have 4 options: A 69760, B 30240, C 99748 and D none of this. Number of words in which all 5 letters are repeated can be written as 10 raised to 5, which is equal to 1000, and the number of words in which no letters is repeated are 10 of P5, that is 30240. Hence the required number of ways can be given as which is equal to 69760, which is our option A. Therefore option A is the correct answer. Question 12. The number of ways of dividing 52 cards amongst 4 players so that the 3 players have 17 cards each and the 4th player just 1 card is. We have 4 options: A 52 factorial upon 17 factorial raised to cube, B 52 factorial, C 52 factorial upon 17 factorial and D none of this. For first set of number of ways are 52, C of 17. Now out of 35 cards, left 17 cards can be put for a second in 35 C of 17, way similar for third in 18 of C 17. One card for last set can be put in only one way. Therefore, required numbers of ways for the proper distribution can be written as 52 factorial upon 35 factorial 17 factorial into 35 factorial upon 18 factorial 17 factorial into 18 factorial upon 17 factorial and 1 factorial into 1 factorial. Further solving this, we get equal to 52 factorial upon, if you see we have 17 in a 3 multiplication, so we write 17 factorial raised to cube, which is our option A. Therefore option A is a correct answer. Question 13. The number of ways in which the letter of the word arrange can be arranged such that both R do not come together is we have four options: A 360, B 900, C 1260, and D 1620. The word arrange has double A, double R, and NGE. Letters. That is two A's, two R's, and one N, G, and E each. So the total number of arrangements can be given as the total number of letters in this, that is 7 factorial upon 2 factorial, 2 factorial, 1 factorial, 1 factorial, and 1 factorial, which is equal to 1260. But the number of arrangements in which both RR are together has one unit, that is we can write as 6 factorial upon 2 factorial, 1 factorial, 1 factorial, and 1 factorial, which is equal to 360. So the number of arrangements in which both R is do not come together, which is equal to 1260 minus of 360, which is equal to 900, which is our option B. Therefore, option B is a correct answer. Question 14. A box contains 2 white balls, 3 black balls, and 4 red balls. In how many ways can 3 balls be drawn from the box if at least 1 black ball is to be included in the draw? We have 4 options: A 64, B 45, C 46, and D none of this. A selection of 3 balls so as to include at least 1 black ball. Selection of 3 balls so as to include at least 1 black ball. Can be made in the following 3 mutually exclusive way. The first way is 1 black ball and 2 others, which can be written equal to 3 of C1 into 6 of C2, which is equal to 3 into 15 equal to 45. For the second way, 2 black ball and 1 other, which is equal to 3 of C2 into 6 of C1, which is equal to 3 into 6, which is equal to 18. Third way, it's 3 black ball and no other, which is equal to 3 of C3, which is equal to 1. So the total number of ways equal to 45 plus of 18 plus of 1, which is equal to 64, which is our option A. Therefore, option A is the correct answer. Question 15. M men and N women are to be seated in a row so that no row women sit together. If M is greater than N, then the number of ways in which they can be seated is, we have 4 options, that is given as in M and N. First, arrange M men in a row. We get as which can be written as M factorial ways. Since N is less than M, so no 2 women can sit together. in any of the m arrangement, that is m factorial arrangement, there are m plus n, m plus 1 places in which n women can be arranged where we can write this as m plus of n p of n ways. By the fundamental theorem, the required number of arrangements of m men and n women for n less than m, we can write this as m factorial m plus 1 p of n, which is equal to m factorial m plus 1 factorial upon m plus 1 minus of n factorial, which is equal to, can be written as m factorial m plus 1 factorial upon m minus n plus of 1 factorial, which is our option A. If we see m factorial m plus 1 factorial upon m minus 1 n plus 1 factorial, therefore option A is the correct answer. Question 16. The number of times the digit 3 will be written when listing the integers from 1 to 1000 is, we have four options: A 269, B 300, C 271 and D 302. Numbers between 1 to 1000 will be 1 digit, 2 digit and 3 digit numbers. Hence number of single digit numbers will be equal to 1. So number of 2 digit number will be, can be written as when 3 is at the unit place, then the tens place can be filled by 9 ways. Hence we get as 9 into 1, which is equal to 9. If you see this is 3 is at unit place and 10 place can be filled by 9. So we get 9 into 1 into 9 ways. For the second, when 3 is at tens place, then unit place can be filled by 10 ways. So this can be written as 1 into 10, which is equal to 10 ways. Number of 3 digit numbers, that is 1, can be written as 9, 10, 1, which is equal to 9 into 10, which we get as 90 ways. For second, we can add 9, 1, 10, which is equal to 9 into 10, 90 ways. And for the third, 1, 10 and 10, which is equal to 100 ways. So total will be 10, that is 100 plus 90 plus 90, which is equal to 280. So total number of times in which 3 is used, which is equal to 1 plus 19 plus of 280, which is equal to 300, which is our option B. Therefore option B is the correct answer. Question 17. 10 persons amongst whom A, B and C to speak at a function. The number of ways in which it can be done if A wants to speak before B and B wants to speak before C is, we have four options, that is A 10 factorial upon 6, B 3 factorial upon 7 factorial, C 10 of P3 into 7 factorial and D none of this. For A, B, C to speak in order to of alphabets, 3 places out of 10 may be chosen first in 10 of C3 ways. The remaining 7% can speak in 7 factorial ways. Hence, the number of ways in which all the 10% can speak is 10 of C3 into 7 factorial, which is equal to 10 of factorial upon 3 factorial, which is equal to 10 of factorial upon 6, which is our options A. Therefore, option A is the correct answer. Question 18. In how many ways can a committee be found of 5 members for 6 men and 4 women if the committee has at least 1 woman? We have 4 options: A 186, B 246, C 252, and D none of this. The number of ways can be deduced as follows, that is 1 woman and 4 men equal to 4 of C1 into 6C4, which is equal to 60. 2 women and 3 men, which is equal to 4 of C2 into 6 of C3, which is equal to 120. 3 women and 2 men, which is equal to 4 of C3 into 6 of C2, which is equal to 60. And for 4 women and 1 man, which is equal to 4 of C4 into 6 of C1, which is equal to 6. So the required number of ways can be given as 60 plus of 120 plus of 60 plus of 6, which is equal to 246, which is our option B. Therefore, option B is the correct answer. Question 19. How many words can be made from the letters of the word Bharat in which B and H never come together? We have 4 options: A 360, B 300, C 240, and D 120. So the total number of words are 6 if we see. So we can write it as 6 factorial upon 2 factorial, which is equal to 360. So the number of words in which the BH come together are 5 factorial upon 2 factorial into 2 factorial, which is equal to 120. And the required number of ways in which B and H never come together. B and H never came together are 360 minus of 120, which is equal to 240, which we get as C. Therefore, option C is the correct answer. Question 20. There were 2 women participating in a chess tournament. Every participant played 2 games with the other participants. The number of games that the man played between themselves proved to exceed by 66 the number of games that the men played with the woman. The number of participants is, we have 4 options: A6, B11, C13, and D none of this. Let there be n men participants. Then the number of games that the men play between themselves is 2. Then n of C, that is 2 into n of C, 2, and the number of games that the men played with women is 2 into 2n. Therefore, further solving, we get 2nc of 2 minus of 2 into 2n, which is equal to 66. By hypothesis, we can say that is n square minus of 5n minus 66 equal to 0. Solving this further, we get n is equal to 11. So the number of participants is equal to 11 men plus 2 women, which is equal to 13, which is our option C. Therefore, option C is the correct answer. Question 21. The number of different words that can be formed out of the letters Mordabad take in 4 at a time, as we have 4 options: A 500, B 600, C 620, D 626. Question 21, the number of so in Murdabad we have 6 different types of letters. That is, we check for Murdabad, that is, if we see we have 3 A's, so we can write for 3 A's. And if we see we have 2 D's, 2 D's, and rest for 4 different. We have to form words of 4 letters. First, all different, that is all different. So 6 of P4 equal to 6 into 5 into 4 into 3, which is equal to 360. 2 different, two alike, 2 of C1 into 5 of C2 into 4 factorial 2 factorial, which is equal to 240. Third, 3 alike, 1 different, which can be 1 of C1 into 5 of C1 into 4 factorial upon 3 factorial, which is equal to 20. So for the fourth one, 2 alike of one type and 2 alike of other type can be written as T of C2 into 4 factorial upon 2 factorial into 2 factorial, which is equal to 6. Further solving this, we check for total number of words, that is total number of words are 360 plus of 240 plus of 20 plus of 6 is equal to 626, which is our option D. Therefore option D is the correct answer. Question 22, how many different words can be formed by jumbling the letters in the word Mispisi, in which number of 2s are adjacent? We have 4 options given. So total letters we see is equal to 11. Number of s's is equal to 4. First place 7 letter and dot place other than s. If we check, if we count this, that is x into, we can write this as x 4 5 6 7 8 9 10 and 11. If we see this, the first 7 letters at dot places other than s can be written as 7 factorial upon 4 factorial into 2 factorial. Now place s at x, place such that the no 2's s are adjacent. So we get as 8p of 4 upon 4 factorial, which is equal to 8c of 4. So total number of arrangements can be equal to 7 factorial upon 4 factorial into 2 factorial plus 8 into c4, which is, making adjustment, we get 7 into 6c4 into 8 of c4, which is our option C. Our option C is the correct answer. Question 23. The sides AB, BC, CA of a triangle ABC have respectively 3, 4 and 5 points, laying one them. The number of triangles that can be contributed using these points are vertices S. We have 4 options: A 205, B 220, C 210, D none of this. In all, there are 3 plus 4 plus 5 equal to 12 points in a plane. The number of the required triangles equal to the number of triangles formed by this 12 points is the number of triangles formed by 12 points minus of the number of triangles formed by the collinear points, which can be written as 12 of C3 minus 3C3 plus 4 of C3 plus 5 of C3, which is equal to 220 minus of 1 plus 4 plus of 10. Solving this further, we get equal to 205, which is our option A. Therefore, option A is the correct answer. Question 24. A committee of 12 is to be formed 9 women and 8 men, in which at least 5 women have to be included in a committee. Then the number of a committee in which the women are in majority and men are in majority are respectively. We have 4 options. So the number of ways in which at least 5 women can be included in a committee, that is 5 women can be included in a committee is 9 of C5 into 8 of C7 plus into 8 of C6 plus 9 of C7 into 8 of C5 plus 9 of C8 into 8 of C4, which can be written plus of 9 of C9 into 8 of C3. Further solving this, for each term we get 1008 plus 2352 plus 2016 plus 630 plus 56, which is equal to 6062 ways. So the women are in majority, so we calculate for women, that is 2016 plus of 630 plus of 56, which is equal to 2702. And the men are in majority, that is for men, this was for women. For men in majority can be said as 1008, so which is we have 2702 and 1008, which is our option D. Therefore option D is the correct answer. Question 25. The number of triangles which can be formed by using the vertices of a regular polygon of n plus 3 sides is 220. Then n is equal to, we have 4 options, A8, B9, C10 and D11. The number of triangles can be equal to 1 of 3 C3, that is number of triangles given as 220, which is equal to n plus 3 of factorial upon 3 factorial and n factorial, which further we can solve this as n plus 3 into n plus 2 n plus 1, which is equal to, can be written as 6 into 220. Further solving this, we get n is equal to 9, which is our option B. Therefore option B is the correct answer. Question 26. If A of n is equal to summation of r is equal to 0 to n, 1 upon NCR, then summation of r is equal to 0 to n, where r upon NCR is equal to, we have 4 options, that is A n minus 1 of into an, B n into an, C 1 by 2 n into n, and D none of this. We have A of n, which is summation of r is equal to 0 n 1 upon CR, and we let Bn be equal to r is equal to 0 to n r of n of CR. So further, Bn can be written as 0 upon n of C0 plus 1 upon NC1 plus of 2 of NC2 with continue of n of NCn, and Bn can be also written as 1 upon n of C0 plus of n minus 1 upon n of C1 plus n minus 2 upon n minus C2 plus continue with plus 0 n of Cn. Since we know that n of C0 is equal to n of Cn, into n of c1, which is equal to n of cn minus of 1 continue has n of cr is equal to n of cn minus r. So by adding both, we get 2bn, which is equal to n of n c0 plus n of n c1 plus continuation of plus n of n cn. So in this, we get n of 1 upon n c0 plus 1 upon n of c1 plus 1 upon n of c2 plus continuation of plus 1 of n of cn. Further solving this, we get 2bn, which is equal to n of an. Taking 2 over there, we get bn is equal to half of n of an, which is our option C. Therefore, option C is the correct answer. Question 27. We have to form different words with the letters of the word integer. Let m be the number of words in which I and n are the never together, and m2 be the number of words which begin with I and end with R. Then m1 upon m2 is equal to, we have 4 options: A30, B60, C90 and D180. We have 5 letters other than I and N, of which 2 are identical, that is ES. We can arrange these letters in n line in 5 factorial upon 2 factorial ways. In any such arrangement, I and N can be placed in 6 variable gaps in 6 of P2 ways. So required number equal to 5 factorial upon 2 factorial into 6 of P2 equal to M1. Now if word start with I and end with R, then the remaining letters are 5. So the total numbers of ways is equal to 5 factorial upon 2 factorial, which is equal to M2. So taking the ratio of both, that is M1 upon M2, we get as 5 factorial upon 2 factorial into 6 factorial upon 4 factorial into 2 factorial upon 5 factorial, which is equal to 30, which is our option A. Therefore, option A is a correct answer. Question 28. If n plus 2 factorial is equal to 250 into n factorial, sorry, this 2550 into n factorial, then the value of n is equal to, we have 5 options, that is A 48, B 49, C 50, D 51 and E 52. We have n plus 2 factorial, which is equal to 2550 into n factorial. Further solving this, taking n on the left hand side, we get n plus 2 factorial upon n factorial, which is equal to 2550. We further solve this, we get n plus 2 into n plus 1, which is equal to 2550. Solving this, we get n square plus 3n minus of 2548, which is equal to 0. We factorize this, we get as n square plus of 52n minus of 49n minus of 2548, which is equal to 0. Further solving this, we get n plus 52 n minus 49, which is equal to 0. So the option we get as n is equal to minus 52 and n is equal to 49. Negative value ignored since factorial is defined for non-negative values. Therefore, we take the positive value, that is n is equal to 49, which is our option B. Therefore, option B is the correct answer. Question 29. If n of C4, n of C5 and n of C6 are is AP, then n is, we have 4 options: A7 or 14, B7, C14, D14 or 21. We know this, that this is given in AP, that is arithmetic progression. So we can write this as 2nc of 5 equal to n of C4 plus n of C4 plus n of C6. This can be written as 2 of n factorial upon 5 factorial n minus 5 the whole factorial equal to n factorial upon 4 factorial n minus 5 factorial plus n factorial upon 6 factorial n minus 6 factorial. Further solving this, we get 2 into 6 n minus 4 equal to 6 into 5 plus n minus 4 n minus 5. Solving this, we get n square minus of 2n 21 n plus 98 equal to 0. Solving this, we do factorization of this equation. We get n minus 7 into n minus 40 equal to 0. So we get answer as n is equal to 7 and n is equal to 40, which is n is equal to 7 or 40, which is our option A. Therefore, option A is a correct answer. Question 30. There are two urns, that is urn A has 3 distinct red balls and urn B has 9 distinct blue balls. From each urn, 2 balls are taken out at random and then transferred to the other. The number of ways in which this can be done is, we have 4 options: A3, B36, C66 and D108. So from urn A, we have 3 red balls, and from urn B, we have 9 blue balls. So the number of ways can be written as the selection of 2 balls from urn A and B each can be written as 3 of C2 into 9 of C2, which is equal to 108. If we solve this further, we get 108, that is option number D. Therefore, option D is the correct answer.